Our speaker is John Mailhot from Imagine Communications, and he's going to be talking about scalable media systems. Simple proofs of concept are kind of old hat now. What we need to do is actually build a media network that can be scaled up as all sorts of demands happen with that. So John is going to give us a really interesting presentation on that. So take it away, John.
Thanks, Wes. All right, hi, I'm John Mailhot, and if this is the talk you came to hear, you're in the right place, and if not, you're stuck. You might ask yourself, what is the Joint Task Force on Network Media? And the Joint Task Force on Network Media is an organization of organizations that are standardizing all this stuff so that as a customer, you can forward to the right. We march this way. Building these IP systems out of SMPTE 2110 and AES 67 and all these related standards, it's a lot of work, right? And if you have multiple vendors, which you want multiple vendors, it's harder. If you want to make bigger systems are harder than small systems. And there's probably even a power law in there that they get much harder, right? They probably go by the square of the size of the system. So how do we as an industry get to where it's not hard, get to where we can make large facilities with mixed formats, doing UHD and HDR and all this new stuff that's coming down the pipe, and use the scale advantage that IP gives us, and yet not have a giant chaotic thing, because it's hard, a lot of work. Okay, that didn't work as well as it was supposed to. So, standards are great, right? And there's about 5 different jokes that start that way. Standards are great, you got a lot to choose from. Standards are great, they're just never finished. There's like 5 different jokes that start out that way. And as an industry, we've built a really good stack of standards for these IP-based systems. So you've got SMPTE 2110, ISO 4, ISO 5, ISO 7, ISO 8. They're all fine standards, and they all say a lot of really good things that are important. But what's missing, right? Because you'd say, oh, all these standards, I just stack up a system. Well, each of them is really, really flexible. Each of those standards gives you some options and some features that you maybe don't need right now. Maybe you'll need them in the future. 2110, we didn't do a great job of speccing profiles and levels, but VSF has picked up that work. Audio streams, everybody's got a different idea on, do we do audio as a bunch of stereo streams? Do we do big 8-channel streams? Maybe we should do 16-channel streams. There's a lot of different ways people think about audio, and it can get complicated because different vendors have made different assumptions about what you're going to do. Things like when you're building a big multicast network, every one of the senders has a multicast address. How do they get configured? Well, if you don't do it some better way, it's just a whole lot of typing. That's not good. And then there's PTP details. Every device has to know the PTP domain and some other details. And again, it's just a lot of information that has to get configured by somebody some way. Well, nobody wants to configure these things by hand, but that's where some of these projects are. So we need to specify, what do you do if you don't do it by hand? Well, what all do we have to configure? Host addresses, masks, gateways, PTP stuff. Where's that NMOS registry? How do I find it? What are the transmit addresses for all these multicasts? Okay, don't know quite why that's going so poorly. And then there's all the normal stuff, like what are all these devices that has to get configured also? Well, persistent settings. So if we're in the television industry, we have some habits about how persistent settings work. So the tradition in television is that, I don't know quite what's going on there. The tradition in television is that if I have a piece of equipment and I configure it, and I turn it off and I turn it back on, it has all the same settings it had a minute ago, right? And you live by that. You count on that happening. Because when operations doesn't like how something's going, what do? They walk back in the rack and they press reset. And they expect it to just come up doing what it was doing a minute ago, except maybe correctly this time. Well, that's great because it leads to a really fast recovery time. But it's also a problem because maybe that thing is really a camera that was just rented, and it's all set up for the last guy who used it. And now you're going to plug it into your big IP network, and it's going to start wailing away on some multicast group that maybe is your program out or your switcher or something, right? A lot of bad things can happen when you misconfigure a device. So there's a similar problem if you have a closet full of spare boards. They've been sitting in there for 2 years, and now suddenly, middle of the night, something fails, maintenance goes, pulls out that spare, and next thing you know, there's all kinds of crazy going on. So, that happens. Well, I'm 6 slides in. I'm usually an optimist, and so far, I haven't said anything good, right? It's all, hey, there's all these problems. Well, so now it's time for the good news part of the sandwich, that yes, there is solutions to these problems. So last fall, the Joint Task Force on Network Media created and published this document, TR1001. So if you go to our website, jt-nm.org, you can read all about this TR1001, and its whole purpose is to fix these problems. So what is it? Well, it was a very fast process. We made a drafting group, a committee of the willing, I like to call it. And the committee of the willing met, and we had a lot of, customers, vendors, other people, all kind of worked together, made this thing, got the document out end of November. So what's it say? Whoops. What it says is use those standards, 2110, ISO 4578, there's a BCP 002 about grouping that's in there. Okay, that's video standards, but it also says use those in specific ways, to use them, sometimes with constraints or with, use it, but use it exactly this way to work around the infinite flexibility problem. And it especially documents these behaviors of when a device starts up, how does it figure out if it's got a good configuration or not? When a device starts up, how does it determine if it's really in the system it was in when it got turned off, or if it just came out of a rental box and it has to wait for instructions? So these behaviors are super important in operating a system. So the first thing it talks about at length is network architecture. So there's a lot of different ideas in the industry on how to organize the media network. Do you have 2 cores? Do you have 1 big core? Do you have 2 logical networks but 1 physical network? All those are perfectly legal. But what we did legislate in this document is that you have to have unicast routing between the networks. So from the management network to the media network, from the media network to the management network, at least unicast things like ping or HTTP have to work. And that's because ISO 4 and 5 sort of depend on those things working. Now, the other thing that we spec'd was a bunch of network hygiene rules, and these aren't mysterious. These are things you almost shouldn't have to say out loud, frankly. These are things like every device interface should have a unique MAC address. Well, I'm sorry, it's 2019. If you make something that doesn't have a different MAC address in every interface, you're just not competent. Every interface has to have its own host IP address. Again, this almost goes without saying, except that occasionally we still see some wacky device that thought they were going to save 3 cents by being strange. And basic things like ping, how do you debug the network? Well, you just got to turn on this stuff, right? Key new thing we're requiring of people is to say, look, use DHCP to get your host address. This isn't radical, right? If you turned on your laptop in your hotel last night and surfed the internet, DHCP was your friend, right? That's how your laptop gets configured every time you turn it on. The same thing with DNS. So we're using DNS, and specifically DNS service discovery, as the way we find the registry, the way we find the system resource, the way we find these other system services. Again, this isn't radical stuff. Your IT team knows how to do this, and they've been wondering for the last 15 years when the broadcasters were going to figure out that there were perfectly good solutions to these basic problems. It's the IT guy in the corner laughing at you as you're hand typing addresses for everything in the system. So equally, we established the concept of system services. So if I'm building a widget that's going to plug into a media network, when it wakes up, what can it expect? So it can expect DHCP, it can expect DNS and DNS service discovery, it can expect to use that DNS service discovery to find a thing called the system resource, which is just a web page. And it serves out a JSON blob, and that JSON blob says, what's the PTP domain? And says what the registry timeout is, and what the PTP announce interval, and there's a handful of other things in there. But the basic system settings that everybody in the plant has to have the same setting, it's in there. You use DNS service discovery to find this ISO4 registry, and then you do ISO4 to that registry. So nodes find it, they register into it. There's this BCP002 grouping, which you'll see a little presentation about over there, that says, you know, if I've got a video and 6 audios and some ANS channels, how do I mark them so that the control system can see that they all go with each other? Because, you know, that's important information, right? And then PTP, of course, is a network service, just like DHCP or anything else. So, it, you know, somewhere it had to say, hey, you know, make sure you do that. Now, one of the focuses we spent a lot of time on in this spec was these device startup behaviors, right? How do you handle the out-of-the-box problem versus the operator just came back and pushed the power button on something? So we say, okay, boxes wake up and do DHCP and DNS and find the registry and register themselves. But how do they know if they're in the same system, and how do they get their transmit information? So the behavior is you look up and you find the DNSSD. You look up in DNSSD, you find the registry, you register. And then in that system thing, there's a system ID. It's just this, you know, random number. And if it's the same as the system you were last in, then you kind of know you're good. And if it's different, then you better shut down, you know, don't transmit anything and wait for someone to configure you. So that's an important safety thing, right? That devices can now tell, hey, I'm new here, someone tell me what's going on. But similarly, in addition to that ID, there's a timestamp in the registry, and there's presumably you keep track of when you were last working. And so that way, a device knows, hey, I've been on the shelf for 2 years, I should, you know, not just come up and run. And so there's a rule about the timestamp and what you do with that timestamp. So between those two things, a device can tell if its configuration is out of place or out of date. And if it's not, then it comes up and goes, because that's the behavior we've grown used to as an industry. But if it's out of place or out of date, then it shuts down its transmitters and waits for instructions, and that's safe. Again, the senders, they need their transmit configuration. So again, if your configuration's out of place or out of date, you clam up and wait, and then a controller comes along and pushes new information into you. Oh, but wait, no spec ever said you had to let a controller push configuration information into you. Well, now it does. Nodes shall support, da-da-da. You know, so that's in this TR that says you've got to do that. So again, it's a catch-all spec that has all these behaviors and other things that if devices follow all these rules, then you can build a system and build it fairly straightforwardly. Now, why is any of this worth doing? Well, I kind of try to make this point along the way. But first off, it's so you can make a system easily. So you can buy devices, open the box, plug them in, and have a path to getting things working quickly. So that's good long term. But secondly, as users, when you write an RFP or a spec to buy equipment, right now, you'd need to write about 10 pages of I want this and this and this, and I want it to work this way. And as vendors, I'll tell you, every customer is going to write that language differently, and it's going to be a crazy, crazy time. So for users, it gives you uniform requirements language. So when you write your spec, your bid specs, or your RFP specs, you can just point to this document and say, implement that or tell me why you didn't. And then that's simple, right? You can, a one-liner in your bid spec makes your whole document shorter because you can leverage this work. And as vendors, it gives us consistent design targets. So we can now target a set of specs that are the same across all the customers. So we both benefit, the vendors and the customers, by having common requirement language. So some people say, well, okay, why is it called TR1001-01? Well, because there are some things that aren't in there that'll probably be in another version of it. So the first of those, and these are future works, is security. So security is on top of mind for many people. If it's not top of mind in your organization, you might ask why. Because in television, we have an especially complicated challenge because we have a transient workforce. So think about the number of people who come into your plant who are there once a week or once every 2 weeks because they work on that one show. And yet, these people that you barely know fundamentally, they go to security in the morning, they get a badge, they walk in, they sit down at some edit station, they plug in their USB drive, they start working. Like every one of them is an infection vector coming into your plant and plugging into a computer. That's not good, but it's who we are. So first off, our peer industries like banking and finance, their first step of security is the front door of the building and who even gets into the building. But because of the way we manage our workforce, we have thousands of transient employees coming and going all week long. Okay, makes it harder. So we have to be really careful about security. So there's a whole set of work around securing the ISO 4 and ISO 5 systems so that you don't have random devices registering and overwriting other things and all kinds of evil behaviors you could have. Now, the second behavior or set of new work is around audio channel mapping. So ISO 5 is really about mapping streams and telling a receiver to take a stream. Well, there might be 8 channels of audio in that stream, and really you're trying to tell a device, hey, I want you to take channel 3 of that stream and do this with it. Well, there wasn't a common language to say that. So ISO 8 adds that common language that you can get audio track level behavior, yet still keep the audio organized in streams on the network in order to keep that layer simple. So at this same time tomorrow, I'm going to give a talk about that. So that's, wait a day or not. And then the third new piece of work is around event flows and tally handling, and how do we do that? Because it's really scary that in 2019 we're still wiring up GPI closure contacts and stuff like that. The tally lamp is still lit with a relay. So funny enough, all 3 of these things are subjects of technology demos over there. So if you go around the back side of that pavilion, you'll see an ISO 7 demo, an ISO 8 demo, and on the end, the security demo. And that's why we brought those 3 demos to this show, was to talk about the 3 new work items, because the old work items, frankly, they're done. And that's the beautiful thing about all these standards, 2110, ISO 4, ISO 5. They've been published. They've been published in some cases for 2 or 3 years. So if the vendor comes up to you and says, well, I'll implement that stuff when it's fully baked, but it's not done yet. No, they're full of crap. It's all done. They just haven't chosen to do it. So that's a different problem, and you should sort that out. These new work items, even they've been around for a while, they're all available on GitHub. They're all publicly visible. A lot of this work is done in the open. So feel free to read up on any of these. AMWA has a GitHub page that has all this stuff on it. So any questions, things I didn't cover, things I should have hit harder?
Kerry, go ahead.
At least it doesn't have a rotten tomato or something.
So since I've been out for the last year, what are the next steps that are going on in the standards bodies related to security? Can you give me details of which group's doing what?
So in the standards groups for security, so the EBU has led the way by publishing requirements. So EBU R143 is a good set of requirements. There's probably an update to that and some new work, and Willem was around just a minute ago, so he's kind of an expert on that. Then the work group that's doing this BCP 001 and 002 is meeting. It's an AMWA group. So our general approach to securing the APIs is to use HTTPS and TLS because that's what all the internet things do and it seems to work. And then now the work is really around defining the roles and the role-based permissions for those, because it's nice to be able to secure the socket, but you still got to be able to say what that individual user is actually allowed to do, because there's different different permissions. And so we're working out the language of how those permissions are expressed.
All right, well, thank you, everyone.